Welcome to the Designing VMware Infrastructure training course. The title of this lesson is Designing vSphere Environments in the Real World. In this lesson, we're first going to start out by introducing the role of a vSphere architect. What is a vSphere architect, and what are the skills and experiences that a vSphere architect should possess? Next, we'll take a look at the different components of a vSphere design, what needs to be included when you create a vSphere design. And finally, we'll review a couple of documents with vSphere design information in them. First up, let's talk about the role of a vSphere architect. It's important to understand a person who designs vSphere environments usually isn't the same kind of person who administers vSphere environments. Designers, or architects as we refer to them in this course, will typically have a different set of skills than an administrator. And this is reflected in the advanced certifications that VMware offers. If you look at the VCAP exams, the VCAP DCA, or Data Center Administration exam, targets those professionals who are going to administer environments. The VCAP DCD, or Data Center Design exam, on the other hand, targets professionals who are responsible for designing vSphere environments. The fact that VMware has two different advanced certification exams reinforces the fact that there's a different set of skill sets that are involved for administrators versus architects. This Venn diagram helps illustrate this concept. On the left, we have a blue circle, which represents the skills that are typically involved in administering a vSphere environment. On the right, a pink circle, which represents the skills for designing a vSphere environment. Now, you'll note that there is significant overlap here. And if we were to compare these regions to the certification exams, you could map that middle region to the VCP, the VMware Certified Professional Exam. It's a common body of knowledge that both administrators and architects need to have about how vSphere operates, the basic concepts behind VMware virtualization, and the products included in the vSphere suite. As you move beyond VCP, however, then we get into these advanced certification exams. VCAP DCA, which would be more applicable to the blue circle on the left, and that is targeted towards those people who are going to be primarily involved with administration of vSphere environments. The VCAP DCD exam, on the other hand, is more targeted at the pink circle on the right, focusing on those skills that are involved in designing vSphere environments. As you can see then, administrators are typically going to go deeper in the day-to-day operational tasks. This includes things like creating virtual machines, creating templates, deploying ESXi hosts in the environment, automating common tasks, and streamlining operational responsibilities. Architects, on the other hand, need to look at a broader vision. Architects need to expand their knowledge into related areas like storage, networking, security, and operating systems. They need to understand the relationships between these components. You'll see me refer to this as the design impact throughout this course, understanding the relationships between these components and understanding the impact that changing one component has on another component. Perhaps most importantly, architects need to take a holistic view of the design. They can't look at the design as individual pieces and parts, but need to look at it as a single holistic entity. This term holistic is an interesting term. I found this definition for holistic and I thought it was very applicable in discussing vSphere design. The definition here, as you can see, describes holistic as characterized by comprehension or understanding that the parts of something are intimately interconnected. That means that when you take a holistic view of a vSphere design, you understand that you can't talk about compute in isolation from storage, or storage in isolation from networking, or security isolated or separate from management. All of these components are intimately interconnected. There is a deep set of interrelationships that exist in the design, and it's important as an architect that you maintain a holistic view of the design, not getting caught down in the individual pieces and parts, but looking at the design as a whole. Now, while I said earlier that the architect and the administrator are typically different individuals, in a small to mid-sized business, those two people could be one and the same. It's not at all uncommon in smaller organizations for both the architect, the person who designed the environment, to also be the administrator, the person who operates the environment. As you move into larger organizations, however, these responsibilities will typically fall to different individuals or different groups. And it's not at all uncommon to see former administrators move into architecture and design at a later point in their career. This is not to say that an architect is somehow above an administrator, just that these two roles are very connected. There is that common body of knowledge, as I showed you in the Venn diagram, and therefore moving from administration into architecture and design is a lateral move that is not at all uncommon to see. With that in mind, what sort of people do we see designing vSphere environments? Very, very common to see vendor or partner consultants or members of the professional services organizations for a vendor or partner performing this function on behalf of customers. It's also not at all uncommon to find organizations that have a dedicated IT architecture group, and that IT architecture group has architects who are responsible for designing vSphere environments within their organization. Now that we've talked about the role of a vSphere architect, let's take a look at the components that make up a vSphere design. It's important to understand that a vSphere design is more than just a diagram. There are a number of different components that comprise a vSphere design. 5 of these components I've listed here on this slide. You would typically find at least these 5, if not some additional components, in a complete and comprehensive vSphere design. You would find, for example, a summary of the design architecture. This is typically a written document that describes some of the design factors. That would include what you're going to build and how you're going to build it, and what led you as the architect to make the decisions that you made in the design. You would also find, not uncommonly, a build or implementation guide. This might be a project plan or simply a Word document or other written document that has step-by-step instructions on how to build the environment as laid forth in the design architecture document. You would also find a summary of design testing and results in order to verify that the architecture design does what you specified it to do. You need to perform some functional testing. We'll talk about that later on in the course. But a summary of the design testing, what tests you conducted, and the results of those tests would often commonly be included in a vSphere design. Operational guidelines. These would be examples of how to do certain day-to-day operational tasks within the environment. And finally, you would find diagrams. Both logical and physical diagrams would typically be included in a vSphere design. We'll talk more about the difference between the logical and physical designs later on in this course. With that information in mind, I'd like to take a look at a few documents that are examples of vSphere designs. One of these documents, the Cloud Infrastructure Case Study, is a publicly accessible document. It was published by VMware in January or February of 2012. You can see the URL here. It's publicly accessible. You can have a look at it. It's regarded as a good example of a vSphere design document because it lays out important concepts in the document. Let's take a quick look at that document. As you can see here, I have the Cloud Architecture Case Study, which is a PDF document pulled up in my PDF application. This is version 1 of the document, published in January of 2012, and again, available off VMware's website. In this document, and I'm just going to flip through some of the pages real quick so you can see what it looks like, we have, of course, a table of contents, and I want to point out a few of the things that I think are important here. Notice in this particular architecture, we have a breakdown of the requirements, assumptions, and constraints, shown here on page 6. These are the design factors. We'll talk about design factors in the next lesson, but they lay out information on how the design should be built and what factors were driving the decisions the architect made in that design. You can see here a list of some of the requirements that were specified in this document. Also found in this document, we have information on logical designs. So if I go back to the table of contents again, you can see that we have a logical design. So if I go down here to host design, this shows information on the hardware that was selected, the platform that was selected. There's also some sizing information found in the previous few pages, how they sized storage, how they sized networking, calculations on sizing CPU and RAM for the host platform. And if we go back even farther, we can see some summary information. This is information that was gathered by the architect before the design was started on how much CPU and RAM was necessary. And here we can see an actual logical design diagram. The logical design diagram doesn't give any specifics, it just gives broad overview of what's going on. We're going to go into detail on logical designs later on in this course, and we'll break down how to create the logical design, similar to what you see here. But as we flip through this document, you can see that it contains many examples of the kind of information that should be included in a vSphere design. So here we have some host design information. I mentioned that earlier. Here's a logical design of the rack layout. You might be wondering why I need to include information on rack layout, because it has an impact on power, cooling, connectivity, availability. Here's information on the vCenter server design, how it's implemented, how Update Manager is implemented, the configuration of the virtual machine that will be running vCenter server. Here's information on the databases for vCenter server and vCenter Update Manager, again a key part of the component. Here they have information on the actual data center design, how many clusters, how many hosts, is DRS enabled, is HA enabled. Again, all this is information you're going to want to include in your vSphere design. Specific settings on vSphere High Availability or vSphere HA. Specific settings on vSphere Distributed Resource Scheduler or DRS and Distributed Power Management or DPM. Some additional logical diagrams on how the cluster is broken down, which networks are available, and then additional network design. Are they using a standard switch or a distributed switch? In this case, they're using a vSphere distributed switch, as you can see there. Here they move into physical design information. How many ports? How many network adapters? What are the port groups? And a more detailed design of what's going on at the networking layer, the interconnects between the distributed virtual switch and the physical switch that sits outside the host. Additional network information such as a configuration for network I/O control. Storage information, the physical design, what solutions were selected, how many disks, what types of disks. How are those disks carved up? Here's a logical division of the storage. In this particular case, they used a NetApp FAS 3240, and they give the layout of how many disks and what type of disks were used. Other additional design implementation considerations, such as the I/O profile, the RAID penalty, the average IOPS that were measured. All this information goes into calculating the storage platform. Here's information on vShield, which was included in this particular case study. So again, a logical layout of how vShield is going to protect the different security zones. Very specific information about the particular rules and zones that were created inside vShield. You can see again a progression from a logical design where everything is high level into a more specific physical design. Again, this concept or this process of moving from logical to physical is something that we'll cover later on in this course. Additional security information. These are some specific hardening guidelines. We continue with hardening guidelines, both for the vSphere host as well as directory services like Active Directory and your virtual machines. Some operational guidelines. Remember that I said you're going to be including some operational information in your design. How virtual machines are provisioned, the standard configurations, how they're going to handle patch and version management, how they're going to handle vCenter server or vSphere client updates. And then there's a conclusion that just wraps up the case study and provides information about the authors of the document. In total, this document is only 38 pages long, so it's a bit on the lean side for a comprehensive vSphere design, but it is a great example that is publicly accessible of something that you could look at to kind of get an idea of how you would structure a vSphere design. I'd like now to show you a document that is not publicly accessible. Unfortunately, it's a document that I created when I was preparing for my vCDX defense. So here you can see a design document that I created in late 2009. This was the design document that I submitted to VMware for my vCDX defense. I've had to go through and sanitize this document, so any customer-specific information has been removed. So you'll see as we go through this document, there are just kind of blank areas where I've had to blank out specific information about their industry, the company name, anything of that nature. But I did want to show you, this is one of several documents that were submitted as part of the design. This is a 58-page architecture design. And this goes through the design factors, what factors led us to make the decisions that we made, what sort of requirements, assumptions, constraints we had to work with. Again, I'm going to go over all those terms and what they are in the context of a vSphere design in the next lesson. But let me just flip through this document real quick so you can see what's involved. A revision history, some other subject matter experts who assisted, and then here you can see the table of contents where we start out with an overview. We then go into an architecture overview, data center design, host design, vCenter server design, network architecture, storage architecture, security, monitoring and management, patch and version management, backup and restore, business continuity, and finally a summary of design assumptions, some implementation recommendations, and then 10 pages of appendices. Those are primarily naming conventions. But in this document, it follows the same sort of logical to physical progression that you saw in the earlier case study, and it's as comprehensive as possible, laying out all of the features, how they're going to be turned on, how they're going to be used. As we flip through this document, I won't take up too much time here. You can see a list of tables, charts, diagrams that were included, quite a few here, 2 pages worth in fact. And then we go into the actual text of the document. Again, it looks a little weird here because I've had to blank out some of the information. But we start out with an executive summary, a business background, what business factors are driving this particular company to adopt vSphere, and what are they trying to accomplish out of it. Here are their target goals and the use cases. Some of our design constraints, what things restricted us in our design. Then into a design overview, calculations on how many hosts were required, similar sort of calculations that we saw in the case study document. Then moving into a data center design, how many data center objects, how many sites, how many clusters, how will HA be turned on and configured, what about fault tolerance or vSphere fault tolerance, vSphere DRS, enhanced vMotion compatibility or EVC. Getting into specific information, this was a vSphere 4 design, so you can see here this design has a section on why VMware ESX versus VMware ESXi was selected. As you move forward into vSphere 5, you'll recall that only ESXi is available, so this sort of information is stuff that you wouldn't find. But logical design on the hosts, then a physical design on the hosts. We then move into vCenter server, databases, database naming conventions and accounts, network architectures, logical design, and then a physical design, security settings. Here we move into more details on the physical design. So you can see this is a fairly detailed document, and again, this is only one. I do have one more document that I'd like to show you, which has some diagrams that came also from this same vSphere design, and it'll show you some of the diagrams that you might expect to see in a vSphere design. So here's the design diagram document. It has a number of pages. There are 7 pages of diagrams here. We can flip through them. A lot of these diagrams were embedded inside the architecture design document. So here's a logical data center overview. Then we have a logical network overview, a physical network overview. You can surmise by this diagram that this particular customer was using HP C7000 blade chassis and HP Virtual Connect in the back. A more detailed physical network overview with uplinks and switches that are handling the various networks. A logical storage overview of the LUNs, the host to which they're presented, and the clusters. A more detailed physical storage overview. How many disks, how many disk pools, how many LUNs. And then an overview of the storage network. In this particular case, they were using fiber channel, so we have a fiber channel storage area network, or SAN, that was involved. This gives you an idea of some of the diagrams that you might expect to see. You may have others, but this is a few that you would commonly find in a vSphere design. And that wraps up this lesson of the Designing VMware Infrastructure video training course. In this section, we introduced the role of a vSphere architect. What does it mean to be a vSphere architect? What skills and knowledge should a vSphere architect have, and what are the tasks that commonly fall to a vSphere architect? What sort of people take on the task of becoming a vSphere architect? We looked at the components of a vSphere design, the different documents and pieces that are included and should be included in a comprehensive vSphere design. And finally, we wrapped up by looking at a few documents that serve as representative examples of vSphere designs. One of those publicly accessible, the Cloud Infrastructure Case Study, and a couple not publicly accessible documents from my own work history in creating vSphere designs for customers. That wraps up this portion of the Designing VMware Infrastructure training course. Thanks for watching.